Hello, and welcome back to General Chemistry 2. This time we will look into another expression of concentration called normality. What is normality? Well, normality is the measure of the concentration of solute in equivalents per liter of solution. In a sense, with this formula, we could also say that your normality N is equal to your molarity times your E, which is in equivalents per mole. What is E? What is our equivalence? Well, equivalence units or your equivalence is used to express the reactive capacity of a chemical species such as electrons or ions. It identifies how many electrons or ions may be transferred in a chemical reaction. For our acid, it is the number of hydrogen ions. For bases, it is the number of hydronium ions. And for salts, it is the oxidation or valence state of the elements. To be able to learn how to compute for normality, we should know how to compute or how to get our equivalents or our equivalent units. Let's practice getting the equivalents of our compound. The first example is HCl or hydrochloric acid. Hydrochloric acid is an acid. Therefore, we just need to count the number of hydrogen ions we have in this compound. Therefore, for HCl, our equivalence is equal to 1 equivalent per mole. For our next example, we have your AlCl3 or our aluminum chloride. For aluminum chloride, we have here a salt. Therefore, to identify the number of equivalents for a salt, we have to look at its decomposition reaction. AlCl3 will decompose to your aluminum ion, Al positive 3, plus your chlorine ion. To balance out the equation, we have to put 3 before your Cl. So, our equivalence is actually the charge of our positive ion, which is our metal. In this case, our E is equal to 3 equivalents per mole. Next, we have another salt in the name of your magnesium chloride. If magnesium chloride dissociates, we will have your magnesium ion at positive 2 plus your chlorine ion negative 1. To balance out the reaction, we will have 2 as the number before your chlorine to balance out 3 atoms on your reactant side and 3 atoms on your product side. Therefore, our equivalent unit is 2, as this is the charge of our positive ion. Now we have your CaO, or our calcium oxide. CaO will dissociate into your calcium ion, positive 2, plus your oxygen, negative 2. Looking again at the charge of our positive ion, our equivalence therefore is 2. Now we have your sodium carbonate or Na2CO3. This will dissociate to your sodium ion, positive 1, plus your carbonate, which is negative 2. Once we balance out the reaction, we will have a coefficient of 2 before your sodium. So we have a question here. Since there is a coefficient for your sodium, what will be our equivalence? Is it 1 or 2? Well, in these cases, if your coefficient is greater than your charge, you will go for the coefficient of your positive ion. Therefore, the equivalence for sodium carbonate is 2 equivalents per mole. Now that we have that part cleared out, we may now proceed with our calculations, starting with this problem. Calculate the normality of the solution obtained by dissolving 0.321 grams of the salt sodium carbonate Na2CO3 in 250 ml of water. Assume the salt solution is being used in a complete neutralization by a strong acid. Let's start our solution by writing our given. the mass of our solute is equal to 0.321 grams, and the volume of our solution is 250 ml. We are required to calculate for our normality. Let's write the general formula for our normality. This is weight of solute all over the molecular weight of solute multiplied to your liters of solution and multiplied again to our E. We have our mass or weight of solution. We have a volume, but we don't have your equivalent units and your molecular weight. Therefore, we will have to calculate for this too. Let's start with our molecular weight. In our Na2CO3, we have 2 sodiums, 1 carbon, and 3 oxygen. The atomic weight for sodium is 23, carbon is 12, and oxygen is 16. This will yield us a molecular weight of 106 grams per mole. Now we've got your molecular weight of solute covered. How about our equivalents? We know that once Na2CO3 dissociates, we will have this equation. Therefore, our equivalence per mole is equal to 2. Now that we've got all covered up, we may now calculate for our normality. Let's see if all our units will cancel out. Grams, mole, ml, and the remaining units will be equivalents per liter. I'm giving you 20 seconds to calculate for the answer. Therefore, the normality of our solution is 0.0242 equivalents per liter. Let's have a relatively easier example with this problem. We have 0.1381 molars of your base, which is sodium hydroxide, and 0.0521 molars of our phosphoric acid. Assuming complete dissociation, let's calculate for the normality. Let's write the general equation for normality using the molarity. It's N is equal to M times your equivalence. We have your molarity on both questions, but we don't have your equivalence. For NaOH, assuming complete dissociation, we will have your sodium ion plus your hydroxide ion. The charge of our positive ion this time is just 1, which means our equivalence is 1 equivalents per mole. On the other hand, for our phosphoric acid, complete dissociation would suggest that we will have 3 units of our hydrogen ion plus 1 unit of our PO4 ion, negative 3. Therefore, the equivalence this time is equal to 3 equivalents per mole. Therefore, now we can calculate for our normality. And on the other hand, we will write 0.0521 moles per liter multiplied with our 3 equivalents per mole. I am now giving you 30 seconds to calculate for the normalities of both solutions. Therefore, the answer for our first solution, which is our sodium hydroxide, is 0.1381 equivalents per liter. For our phosphoric acid, we will have 0.1563 equivalents per liter. Did you get that? And that ends our topic on normality. I will see you in the next video, factors affecting solubility.